Hello everyone, here is Arkady again. Welcome to my technology channel. First of all, I would like to wish everyone a wonderful start of the year. Happy New Year, and I hope 2022 will be a successful year for you. And from my side, I would like to continue my journey on technologies and also looking more detailed on some specific topics in laser cladding. Last year, I had a couple of inquiries which were related to the topic of substrates or base materials. Basically, in laser cladding or any other hard-facing process, we do interact with substrate because we have a metallurgical bonding, and that's why properties of substrates are very important. And today I would like to give you just a brief overview what you have to put attention on and also provide you a couple of examples how certain substrates behave and what methods can be applied to improve the properties of your coating. I have to mention one more thing before we go to the slides, and this is related to the fact that usually most of job shops who do repair or some laser cladding on different variety of parts, their main know-how is related not only process parameters, but also understanding how certain coating material can be put on the top of certain substrate. There are a lot of mappings which help us to understand and just go to some of our databases and look how we can put on 316L, for example, any type of iron-based materials, what we have to look at on what properties in terms of thermal conductivity, surface roughness, or even surface quality or carbon content in your base material can influence your process parameters. Please don't expect from me to share with you any of data because this data is really something which costs a lot of money and which is a know-how of different individual company. My advice would be for you that you, when you as a beginner start to work with substrates, you always save a lot of data, you learn, and that this will be definitely helping you in future to avoid a lot of testing and to have a more structured approach. In any hard-facing process, even in primary we talk here about laser cladding, we put our coating on a substrate. And substrate or base material usually has weaker properties in terms of corrosion, wear resistance, or any other properties compared to your coating. However, the importance of substrate cannot be underestimated. And there are a couple of general rules which can help you to find the right approach, how to interact with the substrate and how to make your laser cladding process look successful. The interaction with substrate does influence two things. First of all, properties of your coating due to dilution and of course diffusion of substrate material to coating and vice versa. And from another side, it does influence properties of your substrate. You can get heat affected zone, you can get cracks, and all those phenomena has to be studied. Sometimes it's also important to understand that looking on your coating properties from just a visual point of view, even pre-grinding your surface and doing dry penetration tests, does not necessarily provide you a right result. So please never underestimate an influence of metallographic investigations. And here's one of the examples where you can see that having some complex cast iron substrates might lead to cracks formation in border region between a coating and substrate, even cracks propagating into the substrate. And understanding this can help you to realize that your process is not always very easy as you imagine, and many defects cannot be found so easy. Let's take a look a little bit on the theory. So if we speak about laser cladding coating versus substrate, mostly we work with the ferrous and non-ferrous substrates, primary metals and their alloys. All those substrates do have different properties. It might be different optical properties in terms of color, in terms of back reflection or absorption of laser light. They might have different thermophysical properties, thermal conductivity, and of course they do have different metallurgical properties, which is based on their chemistry. In my opinion, to have a successfully working process, there are a couple of tips which I can give you. What you have to look on to combine your base material, understanding base material together with your hard-facing or laser cladding process. I would say there are four main directions which go in terms of strategy of your cladding process, which can help to interact with substrate in a better way. And this can be influenced in both ways, working with your hardware, working with cladding strategy, and at the same time changing your process or adapting your process parameters to your coating and substrate needs. Surface quality, which means that sometimes you need to change or achieve a certain surface quality to have a successful process. Coating material, which definitely influence your process and formation of melting bath, because there might be also some differences in case of weldability. Those approaches and understanding where you're coming from can help you to avoid cracking, can help you to avoid porosity, and get a coating of the best possible quality. The most important approach is, of course, strategy. In a strategy, we have a couple of ways how we can optimize our laser cladding process. Instead of working with lines, you can do oscillation and do zigzag called movement. Also, local preheating with inductive heating might help you to achieve very similar results by reducing the cooling temperature and making the cooling process slower. Sometimes we have to understand that those approaches are not enough. If you have been working with welding, then you know a very general rule. To have a crack-free coating in terms also interaction with substrate, you have to be hot as much as possible or cold as much as possible. So sometimes you have to understand that putting directly a hard coating on a certain substrates won't simply work. And to avoid this, especially if we talk about high carbon steel substrates like cast irons, you need a buffer layer, something soft, something which can be easily applied without any carbon, without any carbides building, and after you have to put on top your functional coating. So there are also a way of buffer layer. So sometimes you can simply look on process parameters, playing with energy, shielding gas conditions, and powder flow conditions, which can also help you to minimize your defects and interaction with substrate. The best example for that will be high-speed laser cladding or ELA, where the most of energy goes into melting of your powder and less into interacting with your substrate. Another aspect that we look on is the surface quality. Compared to many other hard-facing processes, requirements on surface quality in laser cladding are not very high. You don't need to sandblast the substrate, you don't need to achieve certain roughness. It's enough to have mechanically prepared surface. What is important? Your surface is free from defects like porosity, cracks, or contaminations in form of oxides, oil films, or galvanic coatings on top, because all those interactions in melting bath will lead to defects. What oils can influence your surface quality or improve your interaction with the substrate? For certain materials, it is related to shielding gas conditions, where you probably need a vacuum, for example, chamber, or shielding gas atmosphere. And at the same time, what people mostly underestimate, for certain materials, overspray particles can be very critical because they land to your substrate, and if you go with your laser beam again, then you might get some troubles in terms of quality. So how you can avoid your overspraying is working with better quality nozzles, or in my opinion, also you can work with your exhaust systems and see how you can get overspray particles away from a surface. Thank you for watching. I hope you enjoyed this short overview about importance of substrate. I'm asking you to give me more topics if you want to learn something about laser cladding. I will be happily to prepare you some interesting stuff and share with you my knowledge. I also would like to invite you to a discussion. As a next step, we will have a couple of interviews, and I'm very, very happy about welcoming first guests soon. And I will try to get a sneak peek to laser markets, how lasers are used nowadays, and what their benefits are. Let's stay in touch, and please give me more of comments, give me more feedback, and write me emails so I can really focus on the subject which might be of your interest. I thank you for your attention and wish you a nice day. Bye.